Hi guys, I want to come and talk to you about our 3D shapes that we've been learning about last week and that your assignments are about this week. We have 3 different categories: curve shapes, prisms, and pyramids. The curve shapes are that have curves, they're rounded, and you should recognize those from last year hopefully. So the top one we have is a cylinder. It looks like a can. Then we have the sphere, which is a ball, and I'm trying to get it to stay still. It might roll away. Then we have the cone at the bottom. Looks like an ice cream cone, upside down. Sphere likes to roll away. And then we have these prisms over here and pyramids, and we'll talk about what makes them prisms and what makes them pyramids. So prisms have 2 identical ends. So the top and the bottom, or each end, are the same, and that tells it its first name. Prism is its last name, and since it has 2 identical ends of rectangles, this is a rectangular prism. Okay, then we have our cube. Our cube is made of all squares. It's very special. Now, since it has 2 identical ends of squares, a cube can also be called a square prism. And then lastly, we have this one, and this end, and the opposite end are both triangles. So, this is a triangular prism. Okay, then we have pyramids. Okay, so prisms have 2 identical, the same ends, opposite of each other. Okay, pyramids have a point on top. Okay, they come to a point, pyramid point, and opposite of the base. So the base is on the bottom. Base is on the bottom. And that tells it its first name. I'll write bottom here. Alright, so we have a point on top and the base on the bottom. And the base on the bottom tells us its name. So as you see, there's a point on top, and on the bottom is a square. Okay, so this is a square pyramid. We could also call it a rectangular pyramid because squares are rectangles. And this one here, point on top, and at the bottom we have a triangle. So it is a triangular pyramid. Okay, so pyramid point, have a point on top, and then prisms have 2 identical ends. So 2 ends that are the same. Okay, and the end shape gives it its first name. Alright, so you'll see FEV next to every shape. And so F stands for face, and faces are the flat parts of the shape. So if you look at our cylinder, we have 2 flat parts. Both of them are circles. So we have 2 faces. Edges. Edges are straight lines. Being a curved shape, just like on a circle has no sides, a flat circle has no sides, there are no edges on the cylinder because it is made of circles. So edges are straight lines. And vertices, V is for vertices, and vertices are points. And so vertices are where the edges meet. If there's no edges, there's no vertices. Okay? Again, with the sphere, there's no flat parts on the sphere, no faces. And then the edges, no straight lines, and no vertices. So the sphere is completely round like a ball. Okay? Then we have our cone. So you can think of a sphere like a ball, cylinder like a can of soda, or a can of beans, which I have here. So you have a can of beans. That is a cylinder. I also found another cylinder, a spool of thread. Those are household things that you might have that would be good examples. And then a ball, of course. You probably have a ball. I have softball for Kelsey and Caden. But you probably have all kind of balls rolling around. And then cone. So cone has one flat face that it sits on, a circle, one face that's a circle. And then it does not have any edges because, again, it's round, so edges need to be straight, so that does not count as an edge. And then it does not have a vertex because it doesn't have any edges. But it does have this special thing at top. It is called an apex. Okay, so the point on top is called an apex. It's a special math term that is opposite the base. So, next up, and I did find an example. A chocolate chip is kind of a good cone example as well at home. Or maybe an ice cream cone. If you have, you can see the bottom of the chocolate chip is flat, circle, and then it kind of comes to a point, rounded point at the top. So, moving on to the prisms. Okay, so we already identified this as a rectangular prism. And rectangular prisms, when you count them, you want to start at the bases, the two identical ends, so 1, 2, and then you can go all the way around. 3, 4, 5, 6. Okay, so there are 6 faces. When you count the edges, you're going to want to start at each end as well. And you'll go 1, 2, 3, 4, flip it over, 5, 6, 7, 8. Now go down the middle. 9, 10, 11, 12. And there's 12 edges on our rectangular prism. Then we have our vertices, is our corners. Again, start at each end. 1, 2, 3, 4. 4 for this rectangle. And there's 5, 6, 7, 8. 4 more for the other rectangle. So we have 8 vertices. And an example of rectangular prism I found, crayon box, which you might have at home. Rectangle, rectangle. Okay, so 2 identical ends of rectangles. And it's made up of all other rectangles. And then a raisin box, rectangle, rectangle. And then the other faces as well are rectangles. Then we have a cube, which is also a square prism. So 1, 2, and then you go around. 3, 4, 5, 6. Okay, so it has 6 faces, just like the rectangular prism. And then if we count our edges, we can start at the bases. 1, 2, 3, 4, flip over, 5, 6, 7, 8, and then go down the middle. 9, 10, 11, 12. So we have 12 edges. And then again we look at our vertices, top and bottom. 1, 2, 3, 4, flip it over, 5, 6, 7, 8. So there are 8 vertices on a cube. Alright, then triangular prism. And so square prism, cube, and rectangular prism all have the same faces, edges, and vertices because they're all made of squares and rectangles. Alright, triangular prism is going to have, we're going to start at the triangles, 1, 2, and then it has rectangles, 3, 4, 5. So there are 5 faces on the triangular prism. And then edges, we'll start at the triangles again. 1, 2, 3, 4, 5, 6. Now down the middle. 7, 8, 9. Okay, so 3 on the bottom, 3 on the top, 3 in the middle. Then our vertices, we have 1, 2, 3 corners at the top, 1, 2, 3 at the bottom. So 3 plus 3 is 6. Okay? And pyramids. Okay? And triangular prism is a hard one to find a household shape for. You might, there's a fancy candy bar that kind of comes in a triangular prism box. Maybe the top of a milk carton would be a triangular prism. But it's hard to find a triangular prism in your home. But it is possible. Cube, a household item for cube is a tissue box. Or maybe if you have a Scentsy potpourri thing, that is a square prism. Those are just some ideas. Let's go on to our pyramids. Okay, so pyramids have our point on top. So we'll start at the bottom base, because that tells us its name. Square pyramid, one face. We'll go 2, 3, 4, 5. And you'll notice all the other faces of a pyramid are triangles. Okay, the only face that is different is the base, the bottom. Okay, so there are 5 faces. And then we have our edges. So we'll start at the bottom. 1, 2, 3, 4. And then we go up to the top. 5, 6, 7, 8. Okay? So 4 on the bottom and 4 leading to the top make 8 edges. Vertices, corners. 1, 2, 3, 4 on the bottom and 1 on top. So that's 5. Then I have my triangular pyramid. Okay, so I'm going to look at the bottom. It's a triangle. I have 1 here, 2, 3, 4. Okay, so there are 4 faces. Then we have our edges. We'll go back to the bottom. Start at the bottom. 1, 2, 3. And then we go up to the top. 5, 6, 4, 5, 6. Excuse me. So 3 at the bottom and 3 going up top makes 6 edges. And then our vertices, we have 1, 2, 3 at the bottom, 1 on top makes 4. Okay, so you'll notice the faces and the vertices are the same for each pyramid. Okay, so they should match, and then the faces and vertices of the triangular pyramid should match. Okay, so there's patterns that you can look for when you're working through your 3D shapes. And I hope that helps you guys get started. And don't forget, on Friday during our Zoom, we will be doing a show and tell. So try to find something in your house that is each of these, or one of these shapes, in order to share with us. So something like the crayon box or a raisin box or a ball. Anything like that would be a great example for you to share with us. Thanks so much. Bye, guys.